Relativity.
General relativity.
Special relativity! Yeah!
Hello there. I'm Dr. Weber, physics professor at College University. Did you know that Albert Einstein's first wife, Mileva Mararik, gave birth to their illegitimate daughter Lisserel in 1902, a year before they first got married? What became of Lisserel is unknown. Einstein then spent 10 years trying to include acceleration in the theory and published his theory of general relativity in 1915. In it, he determined that massive objects cause a distortion in space-time, which is felt as gravity. Albert Einstein, in his theory of special relativity, determined that the laws of physics are the same for all non-accelerating observers, and he showed that the speed of light within a vacuum is the same no matter the speed at which the observer travels. As a result, he found that space and time were interwoven into a single continuum known as space-time. Events that occur at the same time for one observer could occur at different times for another. As he worked out the equations in his general theory of relativity, Einstein realized that massive objects cause a distortion in space-time. Imagine setting a large body in the center of a trampoline. The body would press down into the fabric, causing it to dimple. A marble rolled around the edge would spiral inward toward the body, pulled in much the same way that the gravity of a planet pulls at rocks in space.
So what is relativity?
Well, relativity is divided up into two components, you see. You have general relativity, and then you have special relativity. Now, special relativity came first. This theory was based off of the speed of light being constant for everybody in the known universe. That may seem simple enough, but it has far-reaching consequences. Now, Einstein came to this conclusion in 1905. 1905! That's after experimental evidence showed that the speed of light didn't even change as the Earth swung around the sun. The result was surprising to physicists because the speed of most other things does depend on what direction an observer is moving. Now, if you drive your car alongside a railroad track, the train coming right at you will seem to be moving much faster than if you turned around and followed it in the same direction. Einstein said that all observers will measure the speed of light to be at 186,000 miles per second. That's a lot faster than a train. This doesn't even matter what direction or how fast you're moving. This maxim prompted the comedian Stephen Wright to ask, if you are in a spaceship that is traveling at the speed of light and you turn on the headlights, does anything happen? Ha ha ha! Oh, Stephen Wright. The answer is the headlights will turn on normally, but only from the perspective of someone inside the spaceship. For someone standing outside watching the ship fly by, the headlights do not appear to turn on. Light comes out, but it takes an eternity for the beams to get ahead of the spaceship. As you can see here, this young man is running at the same rate as the car beside him. From the perspective of a bystander across the street, he's moving at a certain rate, say 5 miles per hour. However, from a different perspective, if you viewed this running man from inside the car, it would appear as if he were stationary, because they are both moving at the same rate. Now, according to Einstein's special theory of relativity, if this man were running at the speed of light, he would appear to be moving at that same speed from any outside perspective, no matter that outsider's frame of reference.